Hi everyone, welcome to today's lecture on Six Sigma, which is a data-driven path to zero defects. Six Sigma is actually one of the most powerful quality improvement approaches used by companies worldwide, from massive corporations like Amazon and Boeing to your local hospitals. We are going to explore how businesses use data and systematic thinking to eliminate error and deliver near-perfect products and services. Before we jump into the details, let me give you a roadmap of what we'll cover today. First, we'll answer the fundamental question, what exactly is Six Sigma? We'll look at its definition and core principles. Then we'll explore the Six Sigma organization and its structure, basically who does what in a Six Sigma company. After that, we'll dive into the heart of Six Sigma, the DMAIC methodology. Next, we'll see how Six Sigma works together with another powerful approach called the Lean, creating what we call the Lean Six Sigma integration. Finally, we'll wrap up everything up with a summary that ties all together. This structure will help us to see both the big picture and the important details. So grab your notes. Let's get started. So what is Six Sigma? At its core, Six Sigma is both a philosophy and a practical methodology. Think of it as a mindset combined with a toolkit. The philosophy part means it's a way of thinking about quality, a belief that perfection, or something very close to perfection, is actually achievable. The methodology part means it gives you specific steps and tools to get there. Six Sigma focuses on four key areas. First, reducing variation. Imagine you work at a coffee shop, and every latte you make tastes slightly different. Sometimes too bitter, sometimes too sweet. That's variation, and customers hate it. Six Sigma aims to make every product or service consistent. Second, measuring defects. You cannot improve what you don't measure, right? Six Sigma is all about counting errors and understanding exactly where things go wrong. Third, improving quality across the board, whether that's physical product or like the smartphone or services like your school's registration process. And the last but not least, to promote continuous improvement. That means never settle for good enough. There's always room for gets better. And now here's the really impressive part. The target of Six Sigma is just 3.4 defects per million opportunities. Okay, let's talk about where Six Sigma came from, because the history is actually pretty interesting. Six Sigma was born at Motorola back in the 1980s. Remember, this was when Japanese companies like Sony and Toyota were crushing American manufacturers with superior quality products. An engineer named Bill Smith at Motorola said, enough, enough. And he created his new approach to reduce manufacturing defects, and it worked. Motorola quality improved so much that they won the prestigious Malcolm Baldrige Quality Award in 1988. That's like winning an Oscar for business excellence. But Six Sigma might have stayed just in Motorola if it wasn't for GE. In 1995, GE's legendary CEO Jack Welch adopted Six Sigma company-wide, and the results were staggering. GE saved over $300 million in just 2 years. Soon, Six Sigma spread globally across all industries, not just manufacturing, but spanned to healthcare, banking, and hospitality industry as well. What makes Six Sigma special is that it combines two powerful elements, statistics and measurement. On one hand, we've got a vigorous statistical tool that measure and reduce variation with mathematical precision. On the other hand, we've got a structured problem-solving methodology called DMAIC, which we will explain in detail shortly. But here's the catch. Implementing Six Sigma requires real cultural change and strong leadership commitment. We cannot just buy Six Sigma software and call it a day. The entire organization has to embrace this data-driven and quality-focused mindset from top down. Now let's dig into three fundamental concepts that drive everything in Six Sigma. First one is variation is the enemy of quality. Whether you are manufacturing car parts or processing student loan applications, reducing inconsistency is the path to achieving predictable and reliable outcome, and that's what the customer wants. Second concept, data-driven decision making. And here's where Six Sigma gets really scientific. Six Sigma demands facts and statistics. Let me give you an example. Imagine your manager says, I think customers are unhappy with our delivery times. In the Six Sigma environment, we don't just act at that hunch. We collect data and ask what are the actual delivery times? What are the average? What percentage of delivery are late? Only after analyze those numbers, we will make a decision accordingly. The third concept is focusing on customer requirements. And here's what we meet the term CTQ, critical to quality. These are the specific characteristics or features that customers truly value and care about. And for instance, if you are running a pizza delivery service, your CTQ might be pizza arrives hot, it arrives within 30 minutes, and it made correctly according to the order. So Six Sigma help us identify these CTQs and then consistent deliver on them. It's all about understanding what the customer value and then engineering your processes to deliver exactly that every single time. Six Sigma has the structured hierarchy of roles. At the top, we have the champions. These are typical the senior executive who sponsor the Six Sigma project, remove organization roadblocks, and ensure resources are available. Think of them as a project protector and advocate at the highest level of the company. Next level is Master Black Belt. These are the Six Sigma gurus, experts who not only lead major projects, but also train and mentor others. They are like the professors of the Six Sigma within the organization. Then came Black Belts. These are the full-time Six Sigma experts who lead significant improvement projects. They have deep understanding in statistics and project management skills. Becoming Black Belt typically require weeks of intensive training and successfully completing major projects. Companies often view Black Belts as future leaders because they are doing something to drive real change for the company. Green Belt are employees who have received Six Sigma training and work on projects part-time while maintaining their regular job responsibilities. Maybe you work in a customer service, but you also serve on the Six Sigma team that are trying to reduce call center waiting time. That's a Green Belt role, contributing specialized knowledge while staying in your main position. Now we are getting to the heart of Six Sigma, the DMAIC methodology. DMAIC, which stands for Define, Measure, Analyze, Improve, and Control, which is the structured 5-phase roadmap that Six Sigma teams follow to solve problems and improve processes. What makes DMAIC so powerful is that it's systematic and data-driven at every step. We can't just escape from defined stage straight to the improve based on assumptions. Each phase builds on the previous one, and we need data to progress. Over the next several slides, we are going to break down each phase in detail, look at the purpose of each phase and the tool we'll use, whether we are trying to reduce error in the hospital emergency room, speed up airport security lines, or improve the accuracy of online ordering. DMAIC provides the framework for us to gather. And so let's dive into each phase. The define phase is where every Six Sigma project begins. The purpose in this phase is to establish clear project goals that align with customer requirements. In this phase, we need to answer the following questions. What problem are we trying to solve? Why does it matter? And what does success look like? Let me give you a relatable example. See, our college is receiving complaints that students' wait time is too long to get advice from academic counselors. Before diving into solutions, the define phase would clarify, are we talking about waiting time for walk-ins, appointments, phone calls, or all of three? What departments are affected? What do students actually need from these sections? And we need to scope the project clearly. Six Sigma teams use several key tools in this phase. First, the project charter. Think of this as the project constitution. It documents the problem statement, the project scope, the team's members, the timeline, and expected benefits. It's the document everyone refers back to so that the project doesn't drift off course. Second, there's the SIPOC, which stands for the supplier, inputs, process, outputs, and customers. This is basically a high-level process map that shows you the big picture of how work flows. Who supplies what goes into the process, what are the process steps, what comes out, and who receives it. SIPOC help everyone understand the context. Third, we also gather the voice of customer, which means we listening to what the customers say they need and translate that to specific requirements. Finally, the phase define project boundaries, what's in scope and what's out, and establish success criteria. How will we know if a project succeeded? What metrics will we try to improve? And by the end of the define phase, everybody should have a crystal clear understanding of what we are trying to accomplish and why these matter. Once we have defined the problem, the measure phase is all about collecting data on how things actually work right now. And this phase has three main activities. First, collect process data. This means gather accurate and representative data from the current process. From here, I want to emphasize accurate and representative. If we are measuring defects in the manufacturing line, we cannot just sample one shift on one day. We need to collect data across different shifts, days, and conditions to get the true picture. Second, determine baseline performance. This creates our benchmark, the starting point for us for the future improvement against. Let's say we are working on reducing customer service call time. If the current average is 8 minutes per call, that's our baseline. Third, identify key metrics. Two critical measures in Six Sigma are defects per million opportunities and signal level. They are related to each other. So 1 Sigma is pretty terrible quality, and Six Sigma, which is almost near perfect. and most processes naturally operate around 3 to 4 sigma without focused improvement efforts. And the measurement phase often reveals that organizations don't actually know their current performance as well as they thought. That's actually good news because we cannot improve what we don't measure accurately. Now let's move into the analyze phase. This is the detective work. We are investigating why defects happen and where variation comes from. The goal is to identify root causes, not just symptoms. So let me explain the difference between root causes and the symptoms. Imagine students keep missing assignment deadline in an online course. The symptom is late assignments. But the root cause might be the assignment due date are not clear on the course page, or maybe deadline notifications are not being sent, or perhaps the syllabus has conflicting information. Fixing symptom would mean just penalizing late work. Fixing root causes mean addressing the actual reason why assignments are late. In analysis phase, team use powerful analytic tools. Cause and effect diagram help us to brainstorm all possible causes, and we gather the team and ask what could be possible cause this problem and map out categories like people, processes, equipment, material, and environment. And the second one is the Pareto chart. The Pareto chart, also called the 80-20 rule, says roughly 80% of effects come from the 20% of course. A Pareto chart is a special bar graph that helps us identify the most significant causes, the vital few versus the trivial many. And critically, we need to validate data. We don't just suspect one root cause, and instead we confirm using evidence-based analysis. Maybe we hypothesize that newer employees make more errors. We have to test this by comparing error rates between the new and experienced employees. If the data doesn't support our hypothesis, we change and invest in other courses. This data-driven validation prevents wasting time and resources on improvements that actually don't work because we are targeting the wrong courses. Alright, we have defined the problem, measured the current performance, and analyzed root causes. Now comes the improve phase, where we actually fix things. This phase has 3 key steps. Step 1, develop and test solutions. We brainstorm multiple potential fixes, prioritize them based on factors like cost, feasibility, and impact, and then select the most promising solutions. Step 2, pilot and implement improvements. Once testing validates our solution, we run a limited pilot test, bigger than the test but not full scale yet. We get the feedback from the people actually using the new process, refine the solution based on the lesson learned, and then roll out the proven, refined solution to the full process. And this phased approach manages risk and allows continuous improvement of the improvement itself. The last step is verify the fix. We confirm measurable improvement with new data. Remember that the baseline we established in the measure phase, and now after collection new data, we can compare. Did the setup time actually decreases? Did the error rates actually drop? Now we've made it into the final phase, control phase. This is where we make sure our improvements stick. Sometimes organizations often make improvements that fade away over time as people drift back to the old habits or circumstance changes. The control phase prevents such backsliding. The first major activity is maintaining gains using various control tools. The gold standard here is statistic process control charts. These graphs track process performance over time and signal when something unusual is happening. Think of them like the heart rate monitor in the hospital. If the patient heart rate stays within normal ranges, everything is fine. But if it spikes or drops, alarm goes off. SPC charts work the same way for business processes. The second activity is developing standard procedure and monitoring plans. This means creating or updating standard operating procedure SOPs that document exactly how the improved process should work. And we also need to develop training material so that a new employee learns the right way from day one and the existing employee gets refreshed. Then we define the monitoring plan with clear ownership and frequency. Who is responsible for certain tasks? How often do we need to check? How do they do if they spot a problem? Those details prevent everyone's responsibility, means no one's responsibility is trapped. Here at the bottom line, the control phase lock in our improvements so that they can become the new norm. 6 months or a year from now, the gain we fought hard to achieve are still there, continuously delivering value. Have you ever think about why organizations invest so heavily in Six Sigma? Because there are at least 3-4 major benefits. First, Six Sigma reduces defects and variation. Fewer errors mean fewer customer complaints, less wasted time fixing mistakes, and lower costs from scrap or rework. If you are a manufacturer making car parts, few defects mean few parts rejected by customer. And if you are a service company processing insurance claims, fewer errors mean less time correcting claims and fewer angry customers. Secondly, Six Sigma increases customer satisfaction when we consistently deliver what the customer wants. Remember those CTQ we are talking about? Customers are happier, more loyal, and more likely to recommend you to others. And third, Six Sigma improves efficiency and profitability. When we eliminate waste, reduce errors, and streamline processes, we get more done with the same resources. Remember GE saving over $300 million? This is not unusual for large Six Sigma implementations. Even small businesses see significant saving relative to their size. So last but not least, probably most important long-term benefit is Six Sigma build a data-driven culture. Once people get used to make a decision based on data rather than gut feelings, operation teams will start asking, what does the data say, instead of argue about the opinions. So when we look at all those 4 benefits together, high quality, happier customers, better profitability, and smarter culture, it's pretty clear why Six Sigma has spread across the globe. Lean and Six Sigma are different, but they are also complementary. Lean focuses on eliminating waste and improving flow, making us fast. Its metrics are cycle time, throughput, velocity, and Six Sigma focus on reducing variation and achieving precision, make us accurate. Its metrics are defects per million opportunities and Sigma levels. Lean uses tools like the value stream mapping, while Six Sigma uses statistical tools like control charts. Most organizations today, they want both, fast and accurate. So that's why we have the Lean and Six Sigma. We integrate Lean and Six Sigma, we get the best of both worlds. Lean eliminates waste and speed things up. Six Sigma reduce variation and ensure quality. Together, they create processes that are both fast and excellent. Think about an emergency room. Lean gets patients through quickly. Six Sigma ensure properly care was given every time. Or just imagine the Amazon. Lean make our order being shipped fast, and Six Sigma can make sure that our items are shipped accurately. So speed plus precision equals amazing results. Okay, let's wrap up everything we've covered today with a quick summary to solidify these concepts. Six Sigma is a data-driven approach to reduce variation, and variation is the enemy of the quality, as we mentioned in the previous slide. By focusing relentlessly on consistency and using statistical tools to understand and reduce variability, organizations achieve near-perfect quality, Six Sigma. The DMAIC methodology provides a structured roadmap, each phase built on the previous one, and we cannot skip steps. This discipline is what makes Six Sigma reliable and repeatable across different projects and different industries. Finally, Lean plus Sigma equals speed plus precision. When we integrate both approaches, we create processes that are not only fast and efficient, but also highly accurate and consistent. Thank you for joining me in today's lecture, and see you next time.